question talks about the quadratic pattern 244, then 193, then 148, then 109. Okay, so we can see these numbers are getting smaller, which is fine. The first thing that they want us to do is write down the next term of the pattern. So how would we work out what the next term in the pattern is going to be? How would we do that? Can anybody tell me what's the process that we would follow in order to work out what the next term in the pattern is going to be? What would you guys do? Are you feeling shy, Matrix? Is it just difficult to think it? This time of the term, what do you think? The formula thingy. Yeah, so that's quite right. Okay, so Diana, Amanda, yes. Okay, so we don't have to work out what A, B, and C are yet, Diana, because we're going to do that in question 4.2. But certainly what we can do is we can get this down and we can say, or you could do it on your calculator, and you could say, all right, so our first term is 244, our second term is 193, our next term is 148, and the fourth term is 109. So what we want to do is we want to take term 2 and subtract term 1. So term 2 minus term 1. So 193 minus 244, what's it going to leave us with? We take 193 and we take away 244, what do we get? There we go, cool beans. So negative 51 is perfect, 100%. Okay, and then we've got to take 148 and subtract 193. What do we get? Negative 45. Good, Liam. I quite agree with you. Negative 45 is correct. And then we're going to take 109 and we're going to subtract 148. And what are we going to get? Minus 39. Quite right. Absolutely. So now, in order to be able to work out what the next term in the pattern is going to be, all right, we need to figure out what it is that we're going to take away from 109 to get the next term. So we can see each time we subtract something, the thing that we're subtracting by gets a little bit bigger. Yes, the second difference is going to be 6. That's quite right. So if you said minus 45 minus negative 51, you would end up with 6. That's quite right. And then if you did the same thing here, you would also end up with 6. But what they want here is they want the answer to this. Okay, they want to know what term 5 is going to be. So what is this value over here that we now need to essentially, even though it's a negative number, we're adding the negative number to 109. How are we going to work out what that is? So what happens each time? Our first differences get bigger by 6, quite right. So this would be negative 33. All right, so then we've got to take our 109 and take away 33, and that would leave us with 76. Okay, so the next term of the pattern, whoopsie daisy, is going to be 76. Okay, cool. Yeah, that's it. Well done. All right, perfect. Now they want us to determine the formula for the nth term of the pattern. So when they say to us they want us to find the nth term of the pattern, they mean in the form Tn equals an squared plus bn plus c. So it's our job to work out what the value of the a and the b and the c are. Okay, so how are we going to do that? How are we going to work out what the A and the B and the C are going to be? Thank you, Nick. Okay, so Nick says the first thing that we're going to do is take 2A and make it equal to 6. Quite right, divide both sides by 2. So A will be equal to 3. Cool, all right. Someone else now. What's the next step? Okay, so 3A plus B. All right, so we're going to take 3A. So 3A, so 3A plus B, and we're going to make that equal to negative 51. Okay, so B is going to be negative 51 minus 9, which is going to leave us with how much? Negative. Yes, negative 60 is correct. Okay, negative 60 is right. Well done. Perfect. Good. All right. So now we have to work out the value of C. How are we going to do that? There we go. Thanks, Amanda. Yes, Diana, quite right. So A, which is 3, plus B, which is negative 60, plus C, has to add up to the first term of the quadratic pattern. So in this case, it's going to be 244. So now we can solve for C by taking out 244, taking away 3, and adding 60. What do you guys get as an answer for C? That's just the way that it is, Diana. That's just this particular pattern. Okay, and that's just what they've done. All right, so now we would say that Tn equals 3n squared minus 60n plus 301. Okay, so here, sorry, just going through this again. I think there would be 2 marks for your answer here. There would be an accuracy there, a CA here, a CA here, and I think a CA here as well. So that's where those 4 marks would come from. Okay, good. Yes, Amal. Yes, super clear. Perfect. All right, so we've all got Tn equals 3n squared minus 60n plus 301. So now we need to do 4.3. Okay, so 4.3 next, guys. Which term of the pattern will have a value of 508? What are we going to do here? Okay, Diana, quite right. We're going to take, exactly, Nick, we're going to sub. All right, so we're going to take 3n squared minus 60n plus 301, and we're going to make it equal to 508. Okay, so let's take our 3n squared minus 60n plus 301, and we're going to make it equal to 508. So once we've done this, what's the next step? Okay, so we're going to take the C over, subtract. Okay, we can divide by 3, Nick, if we want to. So the first thing is to get it into standard form. So we've got 3n squared minus 60n, and then we've got 301, take away 508. That leaves us with minus 207. Okay, now if I was you, I would not worry about dividing through by 3 here. I mean, you can if you want to, but I wouldn't worry about that. I think the easiest thing for you guys to do when you get to this stage here is to use the quadratic formula. Okay, so if you don't want to factorize, you don't have to. Something like this would be a horrible thing to have to factorize, especially with that C value of -207. So just use the quadratic formula. Okay, so remember, we've got to show when we use the quadratic formula. It's one of the things that we are required to show. So we would get those marks instead of factorizing. And remember, we're not solving for x, we're solving for n, aren't we? Okay, so we would say here, not x equals, but rather n equals. So n equals negative b, oh, sorry, it's -60, plus or minus, and then b squared would be -60 squared minus 4 times a is 3, and c is -207. And all of that needs to be over 2a. So we would end up with that. Okay. All right, nice. So now that we've got as far as this, we can put that into our calculators. I'm just going to move this down a little bit, and then we can work out what the values of n are. So please do share them with Neliswa and I. What are you getting? Okay, so Kinsani, I'm getting the same answers as you. I'm getting either n is equal to 23 or n is equal to -3. Now, is it possible for n to be a negative number in the context of number patterns? Can n be negative? No, it can't. That's quite right, Diana. It cannot be. It has to be a natural number. Okay, so we're going to put a line through it just like that. And then we're going to say it can only be term 23. Okay, so term 23 is equal to 508 in this particular case. All right, good stuff. Well done, everybody. Let's go and have a look. That was out of 4 marks. Okay, so here matrix, there would be a mark for equating, a mark for standard form, a mark for the formula or factorizing, and then a mark on the answer. Okay, everybody happy with that? Okay, next question, let's have a look at it. Question 4.4. Oh, good. All right, I'm glad you're okay, Amanda. How's everybody else? Let's just check in with you guys. Everybody fine? Cool, Orotile. Thank you, iPhone. Mangaliso was happy. Okay, cool. So let's finish this off and then we can go on to something else. In 4.4, they have asked us between which 2 consecutive terms of the quadratic pattern will the first difference be 453? So how are we going to work that out? Between which 2 consecutive terms is the first difference going to be 453? Okay, so when you say got to work backwards, what exactly do you mean, Diana? Back from T1. I don't understand what you mean by back from T1. What I do know is that this is term 1, this is term 2, this is term 3, this is term 4 of the quadratic pattern. And here, this is term 1, and this is term 2, and this is term 3, and this is term 4 of the first difference. Okay, so the question that they're asking us is between which two consecutive terms of the quadratic pattern. So in other words, up here is our first difference. So in other words, they're going to be 453. Okay, but if we sub 453 into the pattern, then we found the 453rd term, Amal. Okay, that's going to give us the 453rd term of the quadratic number pattern. That's not what they're asking for. Okay, they want to know. So in other words, they're asking us somewhere down here in our pattern, what we're going to find is that the difference between these terms, so one of the numbers over here has got to be 453. So what do we need to do? Anyone got any ideas? Okay, I'll give you guys a moment. Oh, there we go. That's a nice suggestion, Nick. You said make a new TN using the first differences. Absolutely. Okay, because what they're essentially telling us is that 453 is one of the outputs or one of the terms of the first differences. Oh, no, sorry. Yes, no, that's exactly what they're telling us. Sorry, between which two consecutive terms the quadratic pattern. Okay, so now how are we going to work out what the nth term of the first differences are? What sort of pattern is it? So the first differences of a quadratic pattern always make a what sort of pattern? %. Okay, so how would you work out the nth term, Nick? What formula could we use? So if our pattern is linear, okay, so Nick is saying we can use Tn equals A plus N minus 1 times D, which we surely can because our pattern of first differences is indeed linear, right? So we know that in this case, the Tn is going to be 453. When they say to us between which two consecutive terms, which letter, which variable are they expecting us to solve for? Do they want the A? Do they want the N? Do they want the D? So Ibrahim reckons the D. Amal reckons the N. So again, we're just looking at the question again, guys, between which two consecutive terms? Yeah, there we go, 100%. Okay, they want us to calculate the N value. Okay, they want us to calculate the N value. All right, so that means that we need to know what A is and we need to know what D is. So we've got 453, which is our Tn. How do we know what A is? What's A equal to in this case? A is equal to negative 51, quite right, Nick, because that is the first term of our linear pattern, plus N minus 1. What's D, matrix? What's D in this case? There we go. Good, well done. So our difference is 6. Okay, so that gives us 453 equals negative 51 plus 6n minus 6. Okay, so let me just move this up a little bit. Give me 1 second. Okay, now unfortunately, this is in the way, so I'm just going to rub that out and then we can carry on writing here. All right, so I guess what we want to do is leave the 6n on one side and take the other numbers over to the other side. So we've got 453, we need to add 51, and we need to add 6. Okay, and that gives us 510. Okay, so now we can take our 510, we can divide it by 6, and that means that n is equal to 85. So in other words, sorry, I just need to sort something out here. Go. Okay, so if n is equal to 85, it means that the first difference is going to be, because remember it says here between which two consecutive terms. Okay, so it's going to be between term 85 and 86. Okay, so we would need to finish that off. Okay, so between term 85 and term 86. That's when the first difference is always, sorry, not always, is going to be 453. Okay, does that make sense to everybody? How are you guys feeling about that? Good, positive, does it make sense? Cool beans. Okay, so iPhone, no problem. Oh, good, Kamchedo. If we go up and go and have a look at our pattern, can you see over here that, so the one with the two blue arrows, that's our quadratic pattern. And the one with one arrow, that is our first differences or our linear pattern. Can you see that the first term of the linear differences lies between term 1 and term 2? And the second term of our linear pattern lies between term 2 and term 3. So if we have worked out what the value of this term is, or what the n of this term is, then it means that it lies between this one here and that one there. So if we've worked out that n was equal to 85, then it would be between the 85th and the 86th term. Okay, so that's how we would know that it was one more. Okay, because the first term of the linear differences lies between the first and the second term of the quadratic pattern. Okay, so that means that the 85th term of the first differences has to lie between the 85th term and the 86th term of the quadratic pattern. Does that make sense? That's how we would know. Is that making sense? Okay. All right. Okay, so that was out of 3 marks. So here there would be a mark for subbing in, a mark for working out that n was 85, and then a mark for our answer like that. Okay, good stuff. We're nearly there, Matrix. We've just got to do question 4.5 now. So here they ask us to show that all the terms of the quadratic pattern are positive. So all the terms in the quadratic pattern, we just go up and go and have a look at it. So that's 244, 199, 149, 109, etc., etc. It says that they're all positive. How would we do that? No, not using sigma notation, because sigma notation is for a sum and we're not adding anything here. So what they're saying is that none of the outputs in our quadratic pattern can be negative. They're all positive. How would we show that? Any ideas? So our nth term, if you guys recall, is 3n squared minus 60n plus 301. How could we use that? To our advantage. Anybody got an idea? Okay, so if you're not 100% sure, then let me ask you a question. If this wasn't a number pattern, all right, and it was a parabola that was sketched on a graph, instead of writing Tn equals, we could write it like this. We could write it as y equals. So I could write it as y equals 3x squared minus 60x plus 301. Right? And if I was to draw that, it would be a parabola. What shape parabola would it be? You're getting closer, Amal. What shape parabola would this be? Would it be a happy face or would it be a sad face? Exactly. There we go, Nick. You've said the right word. Okay, it would be a happy face. Quite right. It would be a happy face parabola. So it would look something like that. So if it is a happy face parabola, then it's safe to say that the smallest y value that it can possibly have, its minimum, would be at the turning point, wouldn't it? That would be the smallest y value that this particular pattern would be capable of generating. If we can work out what that minimum value is and show that it's a positive number, then it means that every other number has to be bigger than that minimum. So how could we work out what the minimum is going to be? So now we're starting to think about functions, right? So this is a bit more of a level 3 kind of question, because now we have to, it is, Cassandra, it is the turning point. Okay, so the y value at the turning point is our minimum. How would we work out what that y value is? Any ideas, Matrix? How would we work out what that y value is? I mean, if you were doing this in functions, what would you do? Try and think about it like that. Okay, so our minus p and q value, you're not wrong. Okay, Ibrahim, you're saying make it equal to 0. But if we make it equal to 0, Ibrahim, what are we calculating? If we make y 0, what are we calculating? So if y or tn, exactly, the x-intercepts. Okay, so because remember, okay, absolutely. But is that going to tell us anything about the minimum? Are the x-intercepts going to help us work out what the minimum is? Okay, so if that was the x-axis over there, it would tell us this value here and it would tell us this value here. It wouldn't tell us what our minimum is. So not delta, no, because that's the discriminant. So that'll tell us about the nature of the roots. How would we work out the x coordinate at the turning point? So if this was a function, how would we work out the x coordinate at the turning point? There's a couple of ways that we can do it. Yes, Amanda. There we go. There we go, everybody. Look at what Cassandra's just said. Okay, so minus b over 2a. Do you remember that formula from grade 11? Okay, so you would have learned it as x equals negative b over 2a. Okay, and that would allow you to calculate, oh, there we go. Now there's an, shame, you should have just said it, Amanda, even if you were wrong. There's another way that we can do this as well. So this is one way of us being able to do it. Can anybody think of another way that we could do this? So x equals negative b over 2a is quite right. That's exactly what we are going to do. But can anybody... Okay, Cassandra, you can use midpoint formula if you know what the x-intercepts are. Okay, because your axis of symmetry of your parabola is always going to be midway between your x-intercepts. But I mean, we don't want to have to first work out the x-intercepts and then go, and we're doing a whole lot of unnecessary work now. Anyone got any idea? There we go. Well done. Good, Ibrahim. Good, Nick. We could also use the first derivative. Okay, so we could take the first derivative and make it equal to 0. Okay, so we could also use calculus. We could use the first derivative. Okay, because the gradient at the turning point at our minimum, the gradient at that point is going to be 0. Okay, but we're not going to worry about doing that. We're going to go with option number 1. Okay, only now it's not x that we're calculating. Remember, we're working with number patterns, so we're calculating n. So we're going to say n is equal to negative b is going to be negative 60 over 2 times 3. Okay, so that means that n is going to be equal to 60 over 6, which is 10. So the 10th term is the minimum of the pattern. How are we now going to work out what the 10th term is? What are we going to do with 10? Okay, sub it into R. Where would we sub it, Nick? Absolutely. Okay, so we're going to sub it into our Tn formula. Okay, and work out what Tn is. Okay, because remember, Tn represents our outputs. Okay, good, well done. All right, so that's the next step. Let's just go down a little bit. And now we can go ahead and go and sub in our 10. Okay, so our minimum is taking place at the 10th term. So we want to work out what that is. So we're going to say 3 times 10 squared minus 60 times 10 plus 301. Okay, and then we would do that on our calculator. And what do we end up with as an answer? I agree. That's what I got as well. We got 1. Okay, so now all that's left for us to do is conclude. Okay, so the minimum, oopsie, minimum is 1. Okay, and we know that 1 is greater than 0. 1 is positive. Okay, so therefore every term in the pattern must be positive. Yes, Amanda, what do you want to ask? You're welcome to unmute and ask a question. Oh, you want to, how would we work out the maximum? Okay, well, our pattern in this particular case does not allow us to work out a maximum, because for us to be able to work out a maximum, something has to change. Do you know what that is? Yes, Nick, you'd be wrong if you said that. Okay, because it's not n that we're working out. We're showing that all the terms are positive. So we wanted to work out the value of the minimum, okay, which is not n. Okay, the minimum value is an output. It's a tn. N is an input. Okay, so Amanda, if we wanted to work out a maximum, okay, we would need a graph that was shaped like that has a maximum. In which case our pattern would have to be something like this. So Tn equals, and then the value in front of the n squared would need to be negative. So like minus n squared plus 3n minus 4, whatever the case is. Then it's possible for you to work out a maximum. Okay. So in front of the n squared, there would need to be a negative for that to be able to happen. Does that make sense, Amanda? Okay, no problem. All right, how are you all feeling? Is it making sense? Are you happy? Is that okay? Are we all good? Are we happy to move on? Good. Cool. Nice, everybody. Okay, let's go and do another one. All right, so let's do this one. Just make it a little bit bigger, and then we can get cracking on this question. I don't know if we'll be able to do everything here, just depending on our time, but let's just wait and see what happens. Okay, so here we've been given a quadratic number pattern, and this is a little bit mostly thumbs up. Oh, good. That's good, Neliswa. Here, the second term and the third term have not been given. All right, so in place of the second and fourth terms, they've just given us variables. So they've told us there's a quadratic number pattern that goes 4, P, 11, Q, 22, and they've told us that it has a constant second difference of 1. Right, the first thing that they want us to do is they want us to prove or show that P is 7 and Q is 16. So now before we jump in and start working with this question, right, okay, so the first difference would be P minus 4, quite right. So we could start doing that. What we're not allowed to do with this question, with all show that or prove questions, we're not allowed to use the information that they gave us and verify that it's true. So a lot of matrics, a lot of grade 11s make this mistake. So you cannot use the 7 and you cannot use the 16. We have to work out that P is 7 and Q is 16 and pretend like we didn't know that those were the values. Okay, so I see what you guys are getting at here. I think what you mean is you want me to write down the 4 and the P and the 11 and the Q and the 22, and then work out our differences. Okay, so let's do that. So here, this would be P minus 4. I quite agree. This would be 11 minus P. This would be Q minus 11, and this would be 22 minus Q. What would that be? Okay, so here we would end up having to say 11 minus p minus 4. And we'd have to do the same then, we'd have to do the same over there. So this would give us 22 minus q minus 11. And the one in the middle over here would be a mixture of p and q. Now that we've done that, what are we going to do next? Yeah, so we're going to say 11. Fine, I agree with you next. So we've got 11 minus p minus another p, and it would be plus 4, right? How are we going to work out what p is equal to? Go back and look at the question again. Yes, we want to work with like terms. You're quite right, Diana. There we go. All right, so make both equations equal to 100%. Okay, Ibrahim, so this has to be equal to 1 because there is a constant second difference of 1. Good. All right, so now we're going to take minus 2p on the side over here. And then on the other side where we've got 1, we would need to take 1 and take away 4, and then take away 11. And that would give us negative 14. Okay, and then when we divided both sides by negative 2, we would end up with what we were supposed to show. And that is that p was equal to 7. Good stuff. Well done, everybody. Okay, so we don't have to do a simultaneous solution. We can just work in terms of one variable. Okay, and then we can do the same thing on this side of here. We can take 22 minus q plus 11, and we can also make it equal to 1, so that we end up with negative 2q on the left, and on the right we've got 1 minus 11 minus 22 gives us negative 32. And then again, when we divide both sides by negative 2, we end up with q is equal to 16. Okay, so you don't have to solve simultaneously. I mean, I suppose in a sense you are solving simultaneously because you are working out the value of 2 different variables. I can't tell you off the top of my head. Diana, I use all sorts of stuff from all over the place. So this could have actually even been from one of our papers at my school. Yeah. Okay, so okay, is that making sense to everybody? Are you guys all good with that? Okay. Okay, just really important. What you're not allowed to do is you're not allowed to sub in the 7 or the 16, okay? Because then you are not proving or showing, you are verifying. Okay, so as long as you don't do that, you're fine. Okay, so 4.1, they would have obviously given us marks for working out what this second difference was, making it equal to the 1, and then ending up with that. Okay, I don't know exactly where the 3 marks were allocated. I think there should probably be a few more than 3 marks there, but anyway, it doesn't matter. Okay, so that's question 4.1. Now again, they want us to find the general term of the pattern. So this is something that they always ask us. So can Neliswa and I let you guys do that? Can you guys do 4.2 on your own? And then when you've got an answer, you can share it in the chat. So you guys work out what the nth term of the pattern is. Remember, when they want the nth term of the pattern matrix, they want it in the form Tn equals an squared plus bn plus c. Okay, you guys try that on your own. Minus 1.5. As well. We should be 3, 2, and then you would have 2 plus 3 plus That is so weird. Yeah, you're supposed to get fractions. You're supposed to get fractions. Peter, let's see, you got half n squared. That's 2. That's okay. Yeah, that's right. Good, well done. You guys did that really fast. Okay, so what Pilo has shared is perfect. Yep, quite right, Diana. Okay, good. All right, so very quickly, this is what you did. Let's just fly through it. You said that. So we know that the constant second difference is 1. So we would have said 2a equals 1. So a equals 1 over 2. And then 3a plus b is equal to the first term. Okay, so that in this case over here, this was, what did I make it equal to? I said 3, okay, because that would be 3. So that would be equal to 3 over here. So b would be equal to 3 minus 1.5, which would give us 1.5, or 3 over 2. And then we would end up with a plus b plus c, and that would be equal to 4, which means that c would be equal to 2. Quite right. So the nth term, Tn equals half n squared plus 3 over 2n plus 2. Okay, so just because you get fractions doesn't mean that you've gone wrong. Yes, Ken signing quite right. Let's see what else has been said here. Yes, Timna. Good stuff. Okay, now let's see if you can work out the value of n if Tn is 232. And so again, we'll just be quiet. We'll let you guys do this. Okay, so something must have gone wrong, Diana, when you did the quadratic formula. You shouldn't be getting a maths error. I've worked it out as well. I did not get a maths error. So just be careful, go through it again and just look at what you've done. There we go. Okay, so Pilo, quite right. I agree with you. That's exactly what I would have ended up with. Yes, Amanda. Now, can n be negative 23, Amanda? Okay. The answer to that is a resounding no. Okay, so I think this is going to be the last thing that we managed to do. So 232 is equal to half n squared plus 3 over 2n plus 2. All the terms onto one side. And then here you can either do the quadratic formula or you can factorize. The choice is yours, obviously. Let me just move this down a little bit. Let's just see what you guys are saying here. You're also getting an error, Nick. Okay, what I would do here, Nick, is I would multiply through by 2 first. So I would end up with 0 equals n squared plus 3n minus 460. And then I would say n equals negative b plus or minus b squared minus 4ac all over 2a. And you should be getting n is 20 or n equals negative 23. Okay, but obviously n cannot be negative, so we would end up with a positive answer. Yeah, divide through by a half or multiply through by 2 because that'll get rid of the fraction. So maybe Diana, get it into this form first here, where you've got the star. Okay, all right, I'm glad that you got that right. Okay, all right, is everybody cool with that?